All right, now we're going to begin Chapter 4 of Introduction to Aviation. This chapter is titled How an Airplane is Controlled. We'll start off with the axes of an airplane. Lateral axis, all right, the longitudinal axis, and the vertical axis. Those respectively, the movement of the plane in those axes respectively is pitching, rolling, and yawing. Airplane's motion around its longitudinal axis resembles the roll of a ship from side to side. Okay, so you can imagine that airplane's the wings, that's those airplane wings like that, and its longitudinal axis. In light of the adoption of nautical terms, the motion from the airplane's longitudinal axis is called roll. Motion about its lateral axis is pitch. All right, pitching is turn my hand like this, and nose to tail, pitch, pitch, decline pitch, incline pitch. All right. And the movement around the vertical axis is termed yaw, Y-A-W. That's a horizontal movement, left and right. Yaw is, once again on my hand, I'll show you yaw. This is the nose of the plane. It's going through the air like this, kind of swinging back and forth. That's yaw. While traveling on a straight line, it's moving back and forth. Okay. So that's three motions of an airplane: roll, pitch, and yaw. These are controlled by three control surfaces. Roll is controlled by the ailerons, pitch by elevators, and yaw is controlled by the rudder. All these movements center around the airplane's center of gravity. So knowledge about the airplane's center of gravity is imperative for a prospective pilot. Airplane designers locate the fore and aft position of the airplane's center of gravity as nearly as possible to the 20% point of the mean aerodynamic chord. If the thrust line is designed to pass horizontally through the center of gravity, it will not cause the airplane to pitch when power is changed, and it will be no different in moment due to thrust for a power on or power off condition of flight. So maintaining control of the airplane, it's important to have that airplane balanced correctly around its center of gravity for those three motions. Primary flight controls. Airplane control systems are carefully designed to provide a natural feel and at the same time allow adequate responsiveness to control inputs. So you find that at low airspeeds, controls are soft and sluggish, and at high speeds, they are firm, and the response of the airplane to your input is much more rapid. Movement of any of the three primary flight control surfaces changes airflow and pressure distribution over and around your airfoil or wing. That change affects lift and drag and allows the pilot to control the airplane around its three axes of rotation. So there's things that control that. When you input to the stick and control pedals on an airplane, what's happening on the outside of the plane is changing the position of different controls. Ailerons, and you'll find a good figure 2 in your text is a very good figure that makes this very simple to understand. Ailerons control roll about the longitudinal axis. They are attached to the outboard trailing edge of each wing and move in the opposite direction from each other. Differential ailerons. Is when one aileron is raised a greater distance than the other, is lowered for a given movement of your control wheel. This produces increasing drag on the descending wing. that controls adverse yaw. When that plane is trying to pitch and go like that, and also this lateral movement, that helps control that. The elevator controls pitch around the lateral axis. Like the ailerons on small airplanes, elevator is connected to the control column in the cockpit by mechanical linkage. Aft movement of the control column deflects the trailing edge of the elevator surface up. This is referred to as up elevator. And what that does, it controls, it'll put the nose up and the tail down. All right, and vice versa. Push forward on your control column or stick will produce nose down, tail up. The power thrust line and position of the horizontal tail surface on the empennage, remember empennage from your last lesson is the tail section of an airplane, are factors in how effective the elevator is in controlling pitch. Let's see, I'm just going through the notes here to hit on the high points because there's a bit of information in here and I don't want to make this lecture too long. As I've said before, I know that we can all read and understand. And it's much easier to read it and see the descriptions than to listen to me talk about it. Let's see, a stabulator is another surface of the airplane that controls it. It's essentially a one-piece horizontal stabilizer. Anti-servo tabs are incorporated into the trailing edge to decrease sensitivity. And also you'll find a balanced weight. A balanced weight is incorporated on the forward portion of the stabilizer tips. When the control column is pulled back, it raises the stabilizer's trailing edge, rotating the plane's nose up. Pushing the control column forward lowers the trailing edge of the stabilizer and pitches the nose of the airplane down. The canard. The term canard refers to a control surface that functions as a horizontal stabilizer, but it is located in front of the main wings. There's a lot of information here on the canard, and it's how it works as a horizontal stabilizer, much the same way as ailerons do. Your rudder. The rudder controls moving an airplane around its vertical axis. This motion is called yaw, Y-A-W, yaw. Like the other primary control surface, the rudder is a movable surface hinged to a fixed surface, in this case to the vertical stabilizer or fin. Moving the left or right rudder pedal controls the rudder. When the rudder is deflected into the airflow, a horizontal force is exerted in the opposite direction. So by pushing your pedal left, the rudder moves left, alters airflow around the vertical stabilizer, and creates a sideward lift that moves the tail to the right and yaws the nose of the airplane to the left, and vice versa. That concludes your primary controls. Your secondary flight controls. Flaps. These surfaces, which are attached to the trailing edge of the wing, increase lift and induce drag for any angle of attack or angle of approach, which we covered in the last lesson. There's four kinds of flaps: a plain flap, split flap, slotted flap, and Fowler flap. The pros and cons, applications of these are covered in the text. There's also leading edge devices that help control the airplane, and these are leading edge of the wing. High lift devices can be applied to the leading edge of the airfoil. The most common types are fixed slots, movable slats, and leading edge flaps. Another secondary control surface is spoilers. Spoilers are deployed on the wings to spoil the smooth airflow, reducing lift and increasing drag. In other words, to induce the airplane to descend at a more rapid rate than is possible without. And you have trim systems such as trim tabs that get you the finite trimming out of your airplane. around its 3 axes of rotation for maximum efficiency. Just going through the notes here, see what I want to pick up on. So in trim systems, the different types, I'll name them real quick. We have trim tabs, balance tabs, anti-servo tabs, ground adjustable tabs, and adjustable stabilizer. You'll want to go through your text and ensure you're familiar with pros and cons of each and what their application is. All right, that concludes our very brief review of airplane controls. And stand by for Chapter 5 of Introduction to Aviation.